Hey everybody, welcome to Algebra. This isn't a particular section that is in the book. However, it's just something I want to go over because we've talked about the 6 different ways of factoring, but I just kind of want to summarize what's going on here. So by the end of this lesson, you should be able to use characteristics about polynomials to decide which type of factoring to use. So back when we first started talking about factoring, I told you there were 6 types of factoring. So the GCF, factor by grouping, FOIL factoring, complex FOIL, which I call magic number, trinomial squares, and difference of squares. So then I also went on to tell you that you can kind of tell what it is by breaking it up by how many terms there are. So a GCF, there's no set number of terms. You always check for a GCF. But factor by grouping is always 4 terms. FOIL factoring, magic number, and trinomial squares are always 3 terms. And difference of squares is always 2 terms. So what I want to do is I want to get into a little bit more detail as to if you see a problem, how do you know which method to do? So let's start walking through it. First thing you always want to do, anytime it says factor, always check for a GCF first. There's no particular way the problem has to look, so always check, see if there's a GCF. If there is, great, go ahead and do that, and then see if you can factor more. If you can't factor anymore, then the problem's just done. Once you've checked for a GCF, you want to go ahead and count the number of terms. And it could have 2, 3, or 4 terms. Now, if there's only 2 terms, that's a pretty good indicator that it's going to be difference of squares. Now, not every polynomial that has 2 terms is definitely going to be difference of squares. It has to have a certain format. It has to be a squared minus b squared, meaning both terms have to be perfect squares, and there has to be a minus sign in the middle. But a dead giveaway that it's you're going to be looking at that type of factoring is 2 terms. That's the only type of factoring that has 2 terms. Now let's jump on down. Well, if there's 4 terms, well, 4 terms, that's a dead giveaway that you're going to do factor by grouping. Okay? That's probably the easiest one to spot. Okay? Now what if there's 3 terms? There's a couple different things that could have 3 terms. So the first thing you want to do is check, is there an a value? Is there a number in front of the x squared? So if there is no number in front of the x squared, if there's no a value, then we're looking at FOIL factoring. And it has to have the format like this, x squared plus bx plus c. So an x squared, a number with an x, and then a number without the x. As soon as you see that format, you should automatically know FOIL factoring. But what if there is an a value? If that's the case, then we're going to be looking at magic number. So again, it looks very similar to FOIL factoring, except there's a number in front of the x squared. Okay, and we've recently gone through how to do the magic number, but that's how you know when to use the magic number, if there's a number in front of the x squared. Now, it could also be that that number that's in front of the x squared is a perfect square, and so maybe you might want to try trinomial squares. But remember, for trinomial squares, the first and last numbers have to be perfect squares, and the middle number has to check out. Okay? So it has the setup of the first and last are perfect squares, and then once you figure out what the square roots of those 2 things are, you multiply them together, multiply by 2, and that has to be the middle number. But here's the thing, if it is trinomial squares, it can be done with magic number. So it's kind of a shortcut if you recognize it. So of all the different types of factoring, I'm worried about trinomial squares the least. Okay? So what I want to do now is I want to go ahead and do a couple examples and kind of show you my thought process on how do I proceed with each problem. Okay, so you can see I've kind of copied this chart over here. So I'm going to use that as a reference. So the instructions here are just factor. It doesn't say factor by grouping or use GCF. It just says factor. And you have to figure out which way to do it. So on this first one, okay, it's got, I'm going to check for GCF first. So 3x squared. There's no number that goes into 3, 22, and 16. Not all the numbers have x's. So there's no GCF here. So there's 3 terms, and there is an a value. So I've checked for a GCF. There's 3 terms, and it has an a value. So I'm going to do magic number. I'm pretty sure it's not trinomial squares because neither 3 is not a perfect square, and negative 16 really isn't either. Positive 16 is, but not negative 16. So I am for sure going to use magic number on this. So 3 times negative 16, that's a negative 48. That's my magic number. So what two numbers can multiply to be negative 48 but add up to be negative 22? Well, since it's a negative 48, I'm looking at one positive and one negative. So just kind of doing some guessing and checking in my mind, I think we're looking at negative 24 and positive 2. So then that'll split up into negative 24x plus 2x. And then I'll bring down the 3x squared and the minus 16. And then from there, it's just factor by grouping. So I will group up the first two, last two. My GCF in that first group is 3x, leaving behind x minus 8. My GCF in the second group is 2. When I divide by 2, I get x minus 8. So my parentheses match. It's a good day. So final answer, 3x plus 2 times x minus 8. All right, let's take a look at the one right next to it. It looks very similar format. However, I'm noticing that my exponents are much bigger. 4x to the 5th, x to the 4th, x to the 3rd. So I need to check for a GCF. So x to the 3rd is going to be part of it, and 4 goes into all three of those numbers. So I'm going to factor out 4x to the 3rd. And when I do, I get x squared minus 4x minus 12. So I found a GCF, but I always need to ask myself, can I factor any more? And what's in the blue parentheses, that looks like it's got 3 terms, nothing in front of the x squared. So that looks like right here, there's no a value, that's FOIL factoring. So what two numbers can multiply to be negative 12, but add up to be negative 4? Well, I think we're looking at negative 6 and a positive 2. All right, so that's my final answer after I bring down that 4x to the 3rd. And there we go. That's my final answer. Let's go ahead and explore the next problem. Okay, so check for a GCF, 9, 12, 6. 3 goes into all those, but 3 does not go into 8. They're not all even. They don't have x's. I don't think there's a GCF here. But I do see 4 terms, so that's a dead giveaway that I'm going to be doing the factor by grouping. So group up the first 2, group up the last 2. That negative is only on the 6x, so do not put it in between the parentheses. Keep that negative on the 6x. So in my first group, I think we're looking at 3x squared as a GCF, leaving behind 3x plus 4. Since that third term is negative, a negative 6x, I'm going to factor out a negative number. I think we're looking at negative 2. So that gives me 3x plus 4. So final answer, 3x squared minus 2 times 3x plus 4. Final answer. Let's take a look at the one next to it. So is there a GCF? 49, only 1, 49, and 7 go in there, and none of those go into 64, so I don't think there's a GCF. There's 3 terms, And there is an a value. There's that 49 in front of the x squared. So it looks like I'm going to do magic number. So when I go and I do magic number, oh, geez, 49 times 64, that's going to be pretty big, like over 2,000. Now, here's something that stands out to me. 49 and 64, those are both perfect squares. Okay, so maybe, just maybe, we might be able to do trinomial squares on this one. So I'm going to set up one set of parentheses. Square root of the first term is 7x. Square root of the last term is 8. Now, it has to double check against that 2ab. So 2 times 7x times 8. So that's what, 56x times 2 is 112x. Aha! That matches my middle term. So since it's a negative 112x, I'll put a minus sign there, put a square on it, problem done. Now, if you'd wanted to continue with the magic number and gotten whatever 49 times 64 is, that's a pretty big number. But anyways, you could still do it. It would still work. All right? It just popped out to me that 49 and 64 are both perfect squares, so I decided to do trinomial squares. Next problem. First thing I want to do is check for a GCF. Looks like 3 can go into there, and x. So divide by 3x, and I get 4x to the 6th minus 25. So then, ask yourself, can it be factored anymore? Well, it looks like those are both perfect squares. 4 is a perfect square. X to the 6th is perfect. Well, anytime your exponent is even, it's a perfect square. 25 is a perfect square, and there's a minus sign in the middle. So that looks like, right here, difference of squares. 2 perfect squares with a minus sign in the middle. So, what times itself gives us 4x to the 6th? That would be 2x to the 3rd. And then 25 turns into 5 and 5. Make one positive, make one negative. And don't forget to bring down that 3x. All right, last example. And right away, I'm seeing this and I'm thinking, this is going to be factor by grouping. 4 terms, so that's a dead giveaway. So my first GCF is x squared. So x plus 5. Since that third term is negative, I'm going to factor out a negative number, so negative 4. And then x plus 5. My parentheses match, so we're in good shape. So I get x squared minus 4, x plus 5, final answer. Now, wait a second. If you truly believe that's your final answer, you're going to miss out on a point. Remember, whenever you factor, your goal should be, can I factor any more? Okay? Don't just complete this step and then be done with it. Double check. Is there a GCF? Is there some other way I can factor it? Well, I'm taking a look here. That first set of parentheses is x squared minus 4. So I recognize that as difference of squares. So that's going to be x plus 2, x minus 2, and then x plus 5. So always remember, double check. Can you keep on factoring? Well, I hope this lesson was helpful and will help you in the upcoming test and quiz. So if you have any questions, please feel free to ask me. I'll be glad to help out in any way. Hope you have a good one, and I'll see you real soon.